All right. Sana, are we good to go? Am I just sitting here staring? Okay, good. I got a thumbs up. Jeez, y'all. I'm sorry. What's up, chat? VS Code coming at you again with another live stream today, all about Rust, which we're going to get into in just a second. But you know the drill. Make sure you subscribe if you're on YouTube. That's important. And yeah, we've been doing a lot of stuff on TikTok. We're still putting a lot of stuff on TikTok. I actually tried to do a video to explain log4 shell on TikTok. It didn't do too well, but I spent a ton of time on it. What's up, chat? What's up, Derpatron? Nice. Okay. Ketis is here. What's up, Ketis? How you doing, chat? Y'all sleepy on this Thursday? 10 a.m. or 8 a.m. for some of y'all, or 5 p.m. I don't know. Can't keep up with all your time zones. What's up, Wow? How's it going? Did I say that right? How are you? Okay. Rust. Here's the thing. I don't know a lot of things about a lot of things. You know, there's like people who say they know something about everything. I don't know anything about a lot of things. And Rust is definitely one of those things. I think it's a programming language. That's about the extent of my knowledge. So to help us understand more about Rust, we have with us today Ryan Levick. Please welcome Ryan to the stream. What's up, Ryan?
Hey, how's it going?
Good, man. How are you doing?
I'm doing all right. All right.
Good. Is it super early in the morning for you? Like,
no, it's super late in the, well, it's not super late. I'm one of those 5 p.m. people. So.
Oh, where are you at? What's your general location?
I'm generally located in Berlin, Germany.
Okay. And what's your exact street address?
That I will not be saying.
All right, chat, please give Ryan a warm welcome, as you do. Sirkin is here. Sirkin loves Rust. 7 p.m. wherever Sirkin is. So that's somewhere to the east of you?
Yeah.
Okay, I got it right. 2 hours. We could try to guess where Sirkin's located. I'm going to say maybe Romania, or maybe even more east than that.
Yeah, I think Romania is 1 hour ahead of me.
So what happens if you go east of Romania? I'm an American, so I don't know where anything is if it's not in America. You gotta have to work with me here.
There's a whole lot of Asia east of Romania. So.
There we go. That's it. Thank you. Jeez. All right. Ryan, tell us a little bit about yourself and what we're gonna do today.
Great, thanks. I do Rust day in, day out. So I guess I'm the opposite of you, Burke. I know a decent amount about Rust. It is a programming language, so you were right there. And more than that, it's a systems programming language. So there's a lot of like low-level programming in it. And today we're going to be looking at a bunch of stuff in Rust. We won't be able to teach everybody Rust in 20 minutes or whatever. That's a tall order, but we will be able to look at some cool VS Code features and how to make your life easier writing Rust and VS Code.
So people are not going to be able to put Rust on their resume after this live stream?
Unfortunately not. I do have a couple other things on YouTube, so if people want to look me up for some Rust tutorials, maybe after that you can put it on your resume.
Nice. So find Ryan on YouTube and then update your resume, double your salary. That's how the real world works. All right. Ryan, let's get right into it, man, because I'm looking at your agenda here, and you said we're not going to learn Rust, but it looks like you're about to teach it to us. So
yeah, let's see how far we get.
Right.
Let's see how far we get. So I'm just going to throw up a whole bunch of code here for everybody. Obviously, if you've not done any Rust programming before, this probably looks like a whole bunch of gobbledygook to you. But there's probably going to be some familiar things here. We have a main function, a loop, and stuff like that. This program here is a simple program for reading a text file and counting words inside of it. And it basically just loops over and says, what word would you like me to give you the count for? And you can type in, to standard in, like I want to see how many times hello is written in this text, and it will print out the number of times that hello is written inside of the text. So just, let the syntax wash over you here and see this is kind of the default Rust experience in VS Code, what you'll get if you just install VS Code and open up a Rust file. So, it's nice, syntax highlighting and stuff, but not too much more than that.
Yeah, I'm trying to figure out what it looks like syntactically. The colon, the two colons there, what is that? Is that C++ syntax?
I think that's a little bit C++ kind of inspired. It's kind of like a syntactically closest maybe to C++, but also there's a whole bunch of like functional programming stuff in there. So
yeah, I see all the chaining. That's starting to look like JavaScript a little bit.
Yeah, exactly. Yeah, this whole skip and next and stuff like that there. It's a bunch of iterators and things.
Chat would also like to point out that Rust apparently is also a game that a lot of people play.
Yes.
I've not.
It's so much so that actually the Rust subreddit, funnily enough, for a long time, the Rust programming language subreddit would have a bot that would try and spot posts for people posting about the game and point them to the Play Rust subreddit, which is the actual game subreddit. I think they got too much where it was happening all the time. They took it down.
They just gave up.
Yeah.
Well, listen, y'all can be playing Overwatch anyway. And by the way, chat, if anybody plays Overwatch and wants to carry me to gold, it's not a long way. Hit me up. All right, man. I'm sorry.
All right, let's do this.
Going here.
Let's do this. So, you're going to want to have Rust installed. First of all, that's pretty easy to do. If you don't have it installed already on your machine, the best thing to do is install a program called RustUp, which is, if you're coming from the JavaScript world, it's kind of like your MVM. It manages versions of the Rust compiler and stuff like that. And you can get RustUp by going to rustup.rs in your browser, and it'll have an installer for you. And then you'll have RustC, which is the Rust compiler. And you'll have Cargo, which is sort of like NPM. It's a build tool, package manager, so on and so forth, all installed. And that's kind of, table stakes right here. So I can run things like Cargo build inside of my terminal. And I have some warnings here, but other than that, I've built it. And if I want to run my program here, I can do Cargo run down here. You'll see at the bottom of the screen, if I type in hello for my text, we get a panic message because one of our things that we're going to do today is implement a method, which we've not yet implemented. So it says here, not yet implement this method. And
what is a panic message? That doesn't sound good.
Panicking is basically like an unhandled exception. So in Rust, most of the time you don't have exceptions in Rust. Most of the time you're passing around error types and things like that. But when things really go wrong, the program will panic, and that is essentially just like an unhandled exception.
How can you not have exceptions?
Oh, you got to listen to my Rust course then, and I'll tell you all about that. It's actually quite nice to not have exceptions, because then nothing can go wrong. No, I'm just kidding.
Literally, it's impossible to code any errors with Rust. Ryan
exactly.
said it.
So this is all the code that we have down here. It's 37 lines long, and you can see this is where our program is crashing on this to do here, where we're going to be implementing something in our program a little bit later on. But our default experience with VS Code with Rust is, it's got syntax highlighting, which is nice. But other than that, that's about it. Like, you don't get anything like that. You can't hover over and see what counter is. If I want to go to counter, I can't. So we're going to need an extension in order to get additional functionality that's not built into VS Code. So we can go ahead and install that extension. Shall we do that?
Let's do it.
Cool. So unfortunately, right now, the status quo for Rust is that if you type in Rust here, and I'll just type it like this, you'll see this 1.4 million download Rust extension here. Don't install that. That is a legacy extension that is being kind of replaced by something else. And eventually, the replacement will go ahead and replace this extension. It'll work fine. It's not horribly broken or anything like that, but it's definitely not the state of the art. So I would recommend not installing this official Rust extension, but instead installing Rust-Analyzer here, which is next in line here. And this will eventually become the official one. That's going to happen probably this year at some point. So we're going to install that instead.
I feel like that's the one takeaway so far, y'all. If you hear nothing else, hear that this is the right extension for Rust.
Yes,
Lest you install the wrong one.
Exactly.
We should figure out how to fix that in the marketplace. Although I don't know that we can. We don't police
Yeah.
that really that way.
Yeah, I think eventually the Rust Analyzer extension will become the Rust extension, and so it will just be named Rust instead of Rust Analyzer and stuff like that. But
You
that's
know what? You know what
a
they can
whole
do
thing.
though? This who is Matt Clad? Do you know Matt Clad?
Yeah, they're the leader of the Rust Analyzer project, which is now officially a part of the Rust project as well.
So just a suggestion, if you could suggest to them to get that to get verified, it's easy. They just got to go do the process, have a domain, put a TXT record in. That will dramatically improve the reliability of that one as the Rust extension to go to.
Cool. I will definitely pass that message along.
All
Awesome.
righty.
So once we have that installed, then and let's go ahead and close this here. So we have all of our code that we're looking at, and you can see now there's a few more things on the screen. You can see right here this option string here that was not there before. What that's doing is sort of annotating the types that we get. So when we call .skip, it returns an iterator back to us where the item that the iterator yields is a string. And when we call .next, it gives us an optional string back. And so we're getting some nice annotations here. You can see, things are popping up all the time as I hover over them. For instance, if I look at read to string here, it'll pop up with documentation. This is a standard library function, letting me know what the errors are, some examples and stuff like that. And I can go to, the string type if I want to look. Let's click on that. This is literally inside of the standard library. I can see how the string type is implemented and stuff like that, which is kind of fun. So we got a lot more going on. And in fact, if I want to go, look at my counter type that I implemented itself, I can just click on it and it takes me down to line 20 here where I implemented counter. So we've got things like go to, we've got things like hover for types and hover for documentation and stuff like that, all sort of built into Rust Analyzer, which makes things a whole lot easier.
Nice. A couple questions that we got so far.
Yeah.
Is Rust production ready?
Yeah, I mean, I can't say that it's production ready for every single use case out there that you can think of, but there are plenty of people using Rust in production, including at Microsoft. Microsoft uses Rust in production for a few things. And there are a lot of companies out there that use Rust in production. I know, for instance, that I was working on the Rust annual survey, helping out with that. And in fact, when we asked people who adopted Rust if they thought it was worth it, I think it was like 95% of people said that they thought that the cost of adopting Rust was worth it. So
wow,
certainly seems like it's getting there and it's being adopted by more and more companies. So I think so, for sure.
Yeah, that's true. And I know that there's big projects like the Dino project. Chat, y'all know Dino? Are you familiar with Dino, which is kind of like Node, but not Node. Anyway, that's written in Rust. So lots of people out there are using it. Yeah. All right, man. Let's keep going because you got a lot to get through. Chat, I'll get to your questions here. I promise.
Cool. There's a couple other things that Rust Analyzer will give us for free and stuff like that. So if you're coming from the Go world, you might be familiar with the tool called Go Format. In Rust, we have Rust Format, which essentially just formats code in a very standard way so that everybody's code looks more or less alike and stuff like that, which can be quite nice. It's customizable, but typically people use it in a kind of default format. And if I, let's say I do some weird formatting here like this, I've put some spaces in and stuff like that. This is totally valid syntax, but it's not really, well formatted syntax. I'm going to go ahead and hit the save button here, and you see that it popped back into place. So what Rust Analyzer has done for us is detected we have this Rust format tool installed. And by default, when I save the file, it will go ahead and run Rust format for us by default. So our code is always kind of properly formatted how it should be, which is
very nice. I like the languages are including these standard formats as like part of the CLI.
Yeah, I mean, it's the whole thing. You have to install it. I think it doesn't come absolutely by default, but I think every project that I've been involved in has used it. So it's
think about how many world problems we can solve with this, like tabs versus spaces.
Yeah. There's sometimes people who say things like, I don't like the way that it looks and stuff like that. I'm like, just get over it. Like, if everybody's on the same page, then then we just don't even have to worry about these things anymore,
Right.
which can be quite nice.
Right. Just fall in line, chat. Stop thinking for
Yeah,
yourself.
yeah. Come on.
I'm just kidding. I'm joking. All right, man.
So you could see a couple of other things that Rust Analyzer is doing for us. For instance, we're not currently using this field of our counter struct right here, and that's what this yellow squiggly line is saying. It's a warning, and it's basically saying this code is correct, but you're probably doing something that you don't mean to be doing. And what it's saying here is, the field is never read words, and this is on by default because we warn against dead code by default in Rust. And you can see the same thing down here. This local argument to this get count method here is also not being used, and it's warning us about that as well. So we get nice warnings and stuff. So our code, if it doesn't have warnings, is hopefully a little bit more correct than if it does have warnings. I think we can go ahead and get rid of this to do here and actually implement some code, because then we can see how Rust Analyzer will help us with like autocompletion and stuff like that. So I'm going to go ahead and just delete the to do here. And what this method is supposed to do is it gets a word and some string, and it looks inside of our words hash map here up on line 21, which is keeping track of a word and the frequency of the word, how often it appears inside of the text file that we've passed it to. So what we want to do is look inside of our words hash map and grab the frequency that word is being used. So in order to do that, we're going to look at our words hash map here. And you can see as soon as I type dot and then W, it's giving me words here as an autocompletion. It knows that there's a field on self on the counter struct here called words. And I can just go ahead and hit tab here, and it will just go ahead and tab complete it, which is also quite nice. And you can see, things like the error message that it's getting right now. We're not actually returning a number back. We're instead returning a hash map. So let's go ahead and grab the word that we have here. And again, we have a compiler error message here. We're grabbing the word inside of the hash map, but what the hash map actually, and if I do here, what the hash map is actually returning to us is an optional number, because the word might not be in the hash map. It might not exist in the hash map. So we're getting back an optional number here when we want to return a number. So the question to ourselves is, if the word isn't inside of our little database of words here, what should the count be? And I think probably 0 makes logical sense, right? So we'll default to 0 by using a nice little helper function here called unwrap or, and then passing it to 0 here. And in fact, what we have to do, for reasons that you will know very intimately if you know Rust, is throw in a couple of symbols here. This has to do with the memory system in Rust. Rust is a non-garbage collected language. It's a manually managed memory language, just like C or C++. But the nice thing about Rust is that the language will not compile if you screw up. So it shows you nice error messages and stuff like that if you're managing memory incorrectly. And that means that you can write super efficient programs because you don't have a garbage collector or anything like that to deal with.
So yeah, I had this sort of like same, reaction, especially when you see the asterisk. If you were exposed to C++ in college, like I was, right? It was like this knee-jerk reaction to that. So a couple questions here and Chad has brought this up too, is that are we talking about, so first of all, we're talking about a strongly typed language here, yes?
Absolutely. Rust is extremely strongly typed, as static type checking. And in fact, there's that old Haskell adage that if it compiles, it works kind of thing. And Rust doesn't go quite as far as Haskell does, but it certainly has that feeling of, if my program compiles, it's not too far away from being correct and actually doing what I hope.
Right. Compiler is the unit test, as we say. And you said, so memory management is manual, a la Objective-C, early Objective-C and C++.
Yep.
Right. So your big problems in Rust then would be memory leaks, correct?
Yeah. So memory leaks are certainly possible in Rust, but in practice, extremely rare. One thing that you have to worry about in C, for instance, is dangling pointers or use after free errors, all the things where you have a pointer and it points to some junk memory or something like that, that you don't have to worry about in Rust. By default, Rust completely protects from errors like that. So it makes systems programming, which typically is the realm of your C or C++, which I know I have a Ruby and JavaScript background before I did Rust. I was kind of scared of C and C++. Yeah, I was definitely worried about using a systems programming language, but Rust kind of makes that easy and relieves a lot of the worry that you have there.
Okay, so would it be fair to say that like you would use Rust in lieu of C++, right? And that you might like Rust. Okay, now along that same vein, and then we'll keep going. I thought this is a good one. The main benefits of using Rust over Go, maybe in like 30 seconds.
Yeah, sure. I think Go is a really great language to choose, particularly in sort of the cloud native space. Go has a runtime, and so if you're in a let's say you're in a domain, like you want to run on a microcontroller, or you're making a refrigerator or something like that, and the refrigerator has, I don't know, 5 kilobytes of RAM. You probably can't fit a Go runtime and 5 kilobytes of RAM, but you could run a Rust program there. So that's kind of the main advantage of Rust, is that it can run in very constrained environments and extremely efficiently. So even if you get to a point where you think Go is not fast enough for me, which is admittedly rare, Rust probably will be fast enough for you.
All right, the need for speed. All right, what are we doing next?
Cool. So our program has been implemented. It looks like it's compiling. We have no red squigglies and stuff like that. Another cool thing that I'd like to show off for Rust Analyzer is that you're able to very easily refactor code in a way that you might be used to from other languages. So for instance, let's say I'm not happy with contents as a local variable name or as an argument name here. If I go ahead and hit F2 here, I get this popped up here, which shows me I can rename something. And let's say I want to say like file contents is just the best name for this. So I can do that, and you'll see pop down here, contents has been renamed to file contents. And of course, Rust Analyzer is smart enough to know, like, if there's it looks only in the local scope, it understands the local scope, it understands this as a variable here. And if there's something else that's named file contents, like, field or something like that, which shouldn't be renamed, it's smart enough to know, okay, I don't rename this, I'll rename this instead. So it's not just a textual find and replace.
That's nice. Yeah, because refactoring is a great way to annihilate your own planet.
Yeah, exactly. Yeah,
it's too late.
That's the nice thing, one, about Rust Analyzer, and also about Rust, is like because it's so strongly typed and has that static type checking, refactoring is kind of a breeze, because all you have to do is go ahead and change a bunch of code, and as long as it compiles, more than likely you haven't made any really, for lack of a better word, dumb mistakes. At least your program does something.
You said you were a Ruby guy. Did you say Ruby and JavaScript?
Yeah.
And now you're over here singing the praises of strongly typed systems.
Yeah. I am a convert. Yeah. No. That's what happens when you use a type system that actually really works. So there are some languages out there, which I don't want to throw any shade or anything like that. I certainly won't. But there are some type systems which can make you wonder at times, is this all really worth it? And I don't think Rust is one of those. I think Rust is a type system that basically answers, yes, static typing can be very, very worth it.
All right. Sure. Well, as a JavaScript developer, I'm completely unconvinced, but let's keep going. What else do we got?
Yeah. So along with local variable renaming, I'm going to hit F12 here while kind of hovered over counter here, and I can go ahead and rename types as well. So, let's just rename that to counter2, and that's been renamed in all the correct places and stuff like that, which is really great. So we've got good refactoring and stuff like that. And in fact, we'll see usize here as the return type from get count. There's even a couple of assists that I have. Let's say I left this off on accident right here, and you'll see Rust does not like that. It likes to have the arguments have their types and the return type have its type. it will infer types inside of functions and inside of methods, but it wants to have the signature with type annotations. And so we're getting a compiler error message here saying like, you're returning this thing. It's called tuple, this empty, these empty parentheses here. You're returning that, but I'm expecting you to return a usize. For those not familiar with systems programming, usize is basically the size a pointer is. So on my machine, I'm a 64-bit machine. That's 64 bits big here. And so it wants to have that return type there. And I can go ahead and bring up, if I hit on my machine Control and period to bring up this little menu here, and I can go ahead and add the function's return type. And so it will go ahead and infer the return type for me and add it for me to make sure that my code compiles, which can be really helpful if you're kind of rushing through code and things are not compiling. You can use all of these assists along the way to write code for you. And you're saving a bunch of time by not having to write a bunch of code. This is the kind of most basic one. There's a whole bunch of different ones, like converting large if statements to guard statements, to extracting functions, generating code and stuff like that. We can show some of that if you're interested.
Well, I kind of want to dig into the syntax a little bit, Ryan. I know there's a lot here, but as I'm looking at the chat, we're looking at a lot of folks who don't know, like they're seeing Rust for the first time.
Yeah.
Chat, can you verify that for me? I mean, I'm just looking through. I don't think we have a lot of highly experienced Rust devs here. Maybe we do, but so just to dig into this a little bit, because I feel this right here. Okay. So let's look at the syntax, like up near where the IMPI, I suppose that's implementation.
Mm-hmm.
I don't know what that means. Like, is that like class? Like what the heck is that?
Yeah, sure. So Rust is not kind of traditionally object-oriented. There are no classes in Rust. Rust is sort of like C, and that it deals with structs. So we have, structured types that have fields inside of them. But we can, unlike C, add methods, just like in object-oriented languages, to our types. And that's what this impl block does here. We have a type here. We called it counter2. I'm going to rename it back to counter. We have our counter type here. And if I want to add some methods to it, I can create an impl block by typing impl, the name of the type. And then I can add some methods like get count and this new function as well, which are now associated with our counter type.
Okay, so just one more. This what is this weird like half a string syntax here? What is that?
Yes. So this is kind of the I don't know, excuse my French, raison d'être. The reason that Rust actually exists is that it can handle memory. It can manage memory statically. So again, Rust doesn't have a garbage collector. Your memory is manually managed, but at the end of the day, essentially the compiler is inserting, your mallocs and frees for you. So where your code will be allocated and where it will be allocated are being statically determined. But sometimes we want to be able to borrow values. In other languages, this is like pointers and stuff like that. And that's essentially what this is in Rust, this ampersand here. So instead of having a string, we're pointing to string data. That's what this means here. And essentially this tick A, as we say in Rust, is indicating how long that memory lives for. So we're just naming the lifetime of how long this memory will live for. So in our counter here, we're not actually holding on to string data like inside of our type. We have a pointer here to string data that lives somewhere else. Now, if you're coming from JavaScript or something like that, pointers and stuff like that might be like, I don't want to deal with any of that, which I totally understand. But in a systems programming language, again, where we can write operating systems in this, we can write browsers, we can write, rockets to the moon and stuff like that. Sometimes we can't afford a garbage collector, and we need to be able to talk about memory in a way that allows us to say this memory is going to live for a certain amount of time. And after that, it's junk. It doesn't exist anymore. And the great part about Rust is that it allows us to reason about this in a way that in C and C++, that's all just kind of in the programmer's head, and they hope to not make mistakes. Rust enforces that.
Okay, so what I'm taking away from here is two things. One is that Rust is sort of an alternative to C++, that is easier to write, right? It's not, what's the word? There's less to worry about. It tries to do more to help you.
Mm-hmm.
And then the second thing is that I'm not a real developer is the other thing that I'm learning right now.
That's not true. That's
Because
not true.
I
You are a
told
real developer.
chat, do you feel that way? If you don't feel like a real developer, I don't feel like a real developer.
No, I don't.
because yeah, we're just not used. I'm not used to dealing in low level concepts. It's just not something I ever have to worry about.
Yeah. Yeah, I totally get that. I will say one thing I'll say to that, though, is that if you're interested in kind of going down the stack a little bit and exploring that, Rust can be a great way to do that because you can get a little bit deeper down the stack than you might be used to from JavaScript or from Ruby or something like that. But still be sure that the programs that you write are not like doing horrible things where you're corrupting memory and takes days or weeks or years or maybe ever to be able to debug that. Like it's just not possible to do in Rust.
Yeah. Okay, so I know we're kind of at time. We didn't get through even a fraction of what you've got. So here's what I want to do. I need to take a few more questions here. So and in the meantime, producer, can we get a link to Ryan's YouTube videos so that people can go who want to learn Rust in more detail? In the meantime, let's get to some of these chat questions here. You may have already answered this, but I don't remember. Is it object-oriented, fully object-oriented like C#?
So Rust is not object-oriented. It borrows some. So Rust is kind of a multi-paradigm language. It's a little bit functional, a little bit object-oriented, a little bit kind of old school imperative. So you'll find some things in Rust that are familiar to you as a object-oriented programmer. Like this is a method, just like methods that you have in other languages. But there are some things that are maybe less object-oriented than you would expect from languages like C#. So you'll find everybody has something to love in Rust, I guess is what I'm saying.
So what about this one? I think this is important because as I understood Rust, I thought that Rust was created specifically for WebAssembly, but maybe I don't understand that correctly. Like, I thought Rust originated at Mozilla, like historically speaking, and was sort of meant for low-level programming on the web. Is this true?
Yeah, so Rust wasn't created specifically for WebAssembly, but WebAssembly is a great use case for Rust. So if you're looking to do Rust programming on the web, I think WebAssembly is a fantastic place to use Rust for web programming. Rust started at Mozilla, but it was used as a replacement for C++ inside of Firefox. Well, they originally created a kind of experimental browser called Servo. And they started taking parts of Servo that was completely written in Rust and putting into Firefox. So now I think Firefox is something like of the C, C++, and Rust. I think Firefox is now like a third, I think, or something like that, Rust, which is pretty good considering it's 25, 30 years old. So
yeah, it seemed to have taken off quite quickly. I think that just goes to show that there's such a need for an improvement in low level programming because it's just freaking hard to do. Just looking through here, we got so many comments. There was a great one up here that I really wanted to get to. I don't know that I can find it. All right. Let's see here. What else, chat? What else do you want to know from Ryan? We got the link here to Ryan's YouTube videos. Thank you, producer. Everybody thank the producer. Let's see. Can you use Rust for machine learning?
Yes, I think there are people out there who are using Rust for machine learning. Given Rust's low-level nature, I think it's best used in machine learning context when you are not kind of playing with the data, but you really need performance. So you've got a model that already works, so on and so forth, and you just want to run it really efficiently, really fast. Then Rust is a great language to use. If you're just playing with the data, something like Python is going to be probably a better language to kind of just play around with and explore the data, given its loosely typed nature, I guess.
So we're not going to be teaching Rust to high schoolers as like their first programming class, is what you're saying?
I think maybe one day for high school it would be cool to teach Rust for like low level programming. So for systems programming, building like a little operating system or building emulators, which is one of the first projects I did in Rust was build an emulator. It all sounds difficult if you've never done it before, but actually it's really not. It's all just a bunch of bytes floating around, and Rust can make it a lot easier to do.
I feel like that's how everything in tech is, and life just in general, where when you don't understand it, it looks impossibly complicated. I had this when I was investing in the Log4 shell thing. And then once you do understand it, you're like, oh, that's not really that complex. Like it's kind of underwhelming. So yeah,
exactly.
All right, another good question here. How supported is Rust in the cloud? Can you put your Rust in the cloud?
This is a great question. I think it's becoming more supported. For instance, a shout out to myself and to my fellow compatriots who are working on the Azure SDK for Rust, which has just seen its first 0.1 release now. So you can use Azure by using Rust, which is great. And let's not forget about people using AWS out there. I think AWS has a really great SDK for using various cloud services and stuff like that. And recently, there was a tweet from somebody at Google saying that they're hiring now for a Rust SDK for GCP as well. So the answer to that question right now is it's okay. It's pretty good, but it looks like it's going to get a lot better as things go along.
Nice. Still just going through here. Let's see. People talking about Rust Analyzer. This is a compiled language, correct? Right.
Yes,
correct?
It is.
What about Rust in Android?
So Rust is being used like literally inside of Android. There have been several announcements, and Android is mostly open source as well, so you can just see the code. And the Android team, people actually creating Android, have started using Rust inside of Android itself. Now, if you were an Android developer making Android apps and stuff like that, it's certainly possible to use Rust there. And I know of a couple of companies that have done that, but it's not first class supported by Google as a way to make Android apps.
Okay. All right. Yeah. Was what's in Java? Like, no. What do people?
Kotlin.
Yeah. That's not low level, right? That's
application. Yeah. I mean, it's kind of like Java. So
yeah. All right, chat. Anything else that you want to know from Ryan? Now is the time to ask. Ryan, would you like to share your IP address?
I'm good. No, I think I'm good.
Okay.
I hope I haven't done it accidentally.
Yeah, pass on that. What is the learning curve if you're like coming from TypeScript? I think I've seen a couple people in here that were like, whoa, the learning curve.
Right? Yeah. Rust's learning curve is it's certainly not like a Python or a JavaScript, which I think are probably somewhat on the easier side to learn. The thing about Rust is that the compiler is pretty strict. So if your definition of learning something is like getting a program to run, even if that program crashes and doesn't actually do what you hope it to do, then Rust is quite hard, I guess, in that. If your definition of learning something is being able to do something useful, having a robust program, then I think Rust is decently learnable because it prevents you from doing a whole bunch of wrong things. So you just have to get over the initial hump of the compiler is yelling at me, I don't understand what these error messages are. Find somebody who already knows Rust. And the biggest thing I can tell you is just look at the error messages. A lot of times people see an error message and they're used to another language that like has horrible error messages, and they go, oh, it got an error, I don't know what to do. And it's like the error message literally tells you exactly what to write to fix it. And people just aren't used to reading error messages that are helpful. Rust has fantastic error messages. Just read them, try and understand them, and half the time, the answer will be right there, staring at you. So,
nice.
Good luck.
Yeah. Well, one more here that I think is super. This is so important. Definitely want to get this answered. Where can we put feedback for the Bing search engine?
I'm going to leave that one with you, Burke.
Listen, Adish, I appreciate you asking this question. I have no idea. We'll try to figure it out. So let's see a couple last minute things. Let's put that URL back up one more time to Ryan's YouTube channel. There we go. You're going to want to go over there and subscribe. Only if you've subscribed to the VS Code channel first. Definitely do not do that in the wrong order. And then lastly, look, y'all, this is me. I'll put this in the chat. This is me on Overwatch. I need your help. I'm hard stuck silver. If you play Overwatch, you know what that means. You play Overwatch, Ryan?
I've played it, a few times.
Okay, yeah. So please help me. It's more important than Rust. That's not the URL for his YouTube channel. Is that not right? ak.ms/VSCodeLive learn Rust.
We can make it the URL to my YouTube channel. That's fine. I wish that I had I don't think I have a nice fancy one that I can just spit out to everybody. But if you search for Ryan Levick on YouTube, you'll find me.
All right. I'm hoping we can get one up here on the fly. We'll wait just one more second. It's interesting. The longer we stream, the more people that join. It's a very interesting phenomenon.
Yeah. Let's keep going. Come on.
We should. I feel like, I don't know, chat. Would y'all like to see us extend the live stream to like an hour? 2 hours? Like, honest question here. We could go on and on because Ryan's got like testing, advanced programs, adding dependencies, macros, debugging, Rust analyzer. Would y'all be interested in us just going until we get through all that stuff, even if it's 8 hours? Yeah, this is an actual Overwatch stream at that point. This gaming, unranked GM, 24/7. Come on, man. It's all coming from Twitch. The Twitch streamers are so extreme, right? Like they'll stream for like 13 hours every day.
Yeah, I don't get it.
And people are like, how can you stream all day on Twitch for a job? I'm like, that's a heck of a job. You just a 13-hour day every day?
Yeah.
What the heck, man? Listen, for all you Twitch people out there, I feel like I want to make you feel like home here. And so I just want to say thank you for the gifted sub. Appreciate that. Thank you for the 2 months. Roll. Thank you very much. I sound like a proper streamer now. All right, folks, that's it. Thank you for joining us. Yeah, I think we'll look into going a little bit longer. We should have Ryan back and do more rusty type things. Thank you, Ryan.
Come back.
Chad, thank Ryan for his time. Thank you for your time. Have a wonderful rest of your week. And we'll see you back here next Thursday. Maybe we'll go longer next time. We'll see.
Cool. All right.
Bye, everybody.